Hi, my name is Garima, and today I will be showing you how to make ghee, also known as clarified butter. For this, all you will need is a stick of unsalted butter, a metal pot, a stove, and a strainer. To make ghee, you first have to bring butter to a boil. So what I am doing is I have put a pot on the stove and I've set it on high, and I'm now unwrapping butter and putting it in the pot. Unsalted butter is preferred, as either way, the salt will precipitate out along with the milk solids and be strained at the end, so the salt is not needed to make ghee. Heat is needed to clarify butter, as it allows for the milk solids to precipitate out and for the water to evaporate. The milk solids are what cause butter to burn and smoke when cooking, so by removing them, the butter can be cooked at a higher temperature for a longer time. This is similar to an impure product having a lower melting and boiling point than the pure product in previously done experiments. Once foaming is observed, the heat is turned down to medium to avoid burning the butter at the bottom of the pot. Additionally, the butter is continuously stirred. A yellowish thin layer of precipitate is observed forming at the top of the pot. This is the milk solids precipitating, while the steam leaving the pot is the water evaporating. Once the milk solid precipitation is observed, usually around 10 minutes after boiling, the butter is stirred less often, with a quick check every 2 to 3 minutes to check the color of the butter, and the butter is left to simmer. Once the color of the butter has become a golden brown and the precipitate becomes a brownish color, the heat is switched off and the butter is cooled for approximately 20 minutes. During this time, the last of the milk solid precipitates at the bottom of the pot while the foaming is cleared up. As observed, the yellow foam fades to reveal a golden brown liquid butter with dark brown precipitate at the bottom. This shows the completion of the butter's reaction with heat, where the milk solids have precipitated out and the water has evaporated, thus leaving behind melted ghee. Here is a close-up of the clarified butter. At the bottom, you can see the dark precipitate as well as on the sides of the pot. There is still minimal foaming, but the rest of the melted butter is now a dark golden brown color. Okay, so now that it's cooled down to approximately room temperature, I've cooled it down for 20 minutes. We're now going to strain it into a glass jar. So here I have a strainer, here's the pot, you just slowly pour it in. This is just to remove any of the excess milk solids that have precipitated out, as the water has already evaporated while cooking it. And as you can see in this jar, it's a golden brown color. And now you've made ghee. You just need to let it cool down and then it's done. And as you can see over here, the milk solids that precipitated out are left behind in here, as well as in the strainer, and this leaves fully clarified butter. Be sure to leave this to cool down all the way with an open lid. You do not want to trap anything inside. You want it to be cooled down with an open lid, and this will take around 5 to 6 hours, and the color will go from this golden brown color to a yellow color, and it will become more solidified. As you can see here, the ghee is solidified into a light yellow butter with a creamy texture. This marks the completion of the entire reaction, as the ghee has now fully cooled to room temperature. It can be stored in a fridge or a cupboard. It is important to allow the ghee to fully cool to room temperature before placing in a fridge to allow for proper solidifying. If put in a fridge while hot, the ghee will not solidify properly and the texture will not be creamy as desired. This is similar to recrystallization. As for that process, the reaction mixture must also be cooled to room temperature before being put in an ice bath to prevent impurities from being trapped in the crystal lattice structure and to allow for larger crystals to form. Ghee, or clarified butter, has a higher melting and boiling point than regular butter. This is due to milk solids and water being removed, thus creating a more pure butter. As seen in experiments over this quarter, An impure compound has lower melting and boiling points due to the impurities disrupting the crystal lattice structure, so the removal of the impurities allows for the proper crystal lattice structure of the compound to form, thus increasing its tolerance against heat. Additionally, this process can be likened to recrystallization, a chemical process that requires heat to purify a product, as the water and milk solids are removed through heat and form a more pure product. Clarified butter also has a longer shelf life, as the milk solids are what spoil first in the butter, so without them, the butter can last longer. Thus, ghee, or clarified butter, is created through the separation of water and milk solids from regular butter, leaving behind pure butter fat. The water evaporates off while boiling, while the milk solids precipitate at the bottom of the reaction, thus separating each component of the butter by density. The leftover product then has a higher melting and boiling point, and allows for a greater variety of cooking uses than regular butter.